what I'm going to do here, this is a presentation that Becky Bell, who used to be on the set panel for Site, prepared for a workshop we did a couple of years ago. And luckily for me, it uses a proposal that we put together on the Corinth Rift. So hopefully I'll not do too terrible a job at showing it to you. And yeah, if Uisdean comes along, he can take over. Okay, so site survey requirements. So this is all about, where should I drill, and demonstrating to SEP and EPSP and everybody else that you're choosing appropriate sites and you'll be able to do what you propose to do with the sites you're going to drill, and that you can deal with all of the various safety and environmental questions that might be raised as well. So you choose the sites and you're responsible for demonstrating the feasibility of that proposed site via site characterization data and imaging of the site, and with that carefully working out the drilling strategy. So the site characterization data requirements do vary according to the objectives and the nature of the site and what you're drilling. But you should, in all cases, demonstrate and be sure that your proposed sites are correctly positioned. So you do need accurate navigational information about the data that you have, and the drilling targets that you've chosen are adequately imaged. So this is the sort of stratigraphic or structural targets that you're proposing to drill, that they're well imaged and that they lack structural or stratigraphic complications, unless you're after drilling a structural or stratigraphic complication. So we strongly advise that every proponent team, and in fact I think this is now a requirement, has a lead data scientist. And that should be somebody who's got some experience with using and handling seismic reflection data in particular, and also bathymetry data. So I believe that is now a requirement. There has to be a data lead for every proposal. So we're going to use an example, which is the Corinth Rift in Greece, just to kind of show the sorts of things that you should be doing in terms of putting together the site data package. So the Gulf of Corinth is an active rift. It's already got a lot of subsurface data, so seismic data. And so we know quite a lot about the character of the stratigraphic section and also the structures that are relevant. There's no deep drilling here, so we've got fairly limited lithology and stratigraphic age, and that's really one of the things we were after here. So what we were trying to do was to drill and get as complete a section as possible of the Sin Rift sedimentary fill that was in the Gulf of Corinth. So that was our aim. And so this was a proposal which I'll talk about tomorrow morning as well. So here's an example of a seismic line. This is actually a Ewing seismic line. So this is sort of conventional air gun, sort of fairly deep penetrating seismic data. And I think this was supposed to be a quiz for you in terms of where should you drill if you want to get a full sequence of the Sin Rift fill. So Becky had put on some examples of places where you probably shouldn't drill. Hang on a minute, we have a poll for our party. So you wouldn't want to drill in this area where you'd get a very thin part of the sedimentary section and quite a bit of basement. And over here, again, you'd get a thin bit of sedimentary section and basement. Over here, you'd be drilling through a fault, and here also the section is thicker. So if we wanted to get a long time history, we'd actually get less of that time history. And so our best bet is this green one here. So this is where you would put your site, because you'll get hopefully a complete sequence, but as long a record as possible of the Sin Rift fill. So what should you be looking for in the site? So you're looking to aim to recover the material you need to address your science question. So if you want a continuous paleoclimate record, you want to avoid unconformities, mass transport deposits and faults, and look for evidence that you've got a continuous record without unconformities and hiatuses. Whereas if you want to sample a fault, you would need to drill through a fault, although that's challenging. And also, of course, you need to image the fault as well, if that's your target. And you need to drill deep enough to recover the material that enables you to reach your science objectives, bearing in mind the limitations of the platforms and the project time constraints. And that did become an issue in this particular project, because it was a mission-specific platform and there were limitations in the depth that we could drill to. So we really were after the balance of getting a continuous a long sequence, but not so thick that we had no chance of getting anywhere further back in time, and therefore really limiting what we could do. Oh, sorry. Whoops. So this is an interpreted section, and it shows where we did put in indeed one of our sites, where luckily I picked the right one, so that's good. So it shows the sort of level of interpretation that you would need. So you need stratigraphic interpretation and structural interpretation of the data when you provide that to the panel. So what sort of data do you have to provide? So digital seismic data is required. And we have had some cases where there might be analog seismic data, but you really do need to be able to image the material and the site. And so really you do need digital seismic data, single channel or multi-channel seismic data, depending on the structural or stratigraphic complexity. So multi-channel if it's more complicated. You need to provide also the acquisition and processing parameters and the velocity data, which is really important because obviously ultimately you're going to say, I want to drill to this depth, and you need to know where that is on your seismic line. Images of your seismic profiles with interpretations, which I just showed, and navigation data for your seismic data. In addition, you need to provide bathymetry data, so some kind of digital grid, and that needs to be reasonable enough resolution, but obviously it does make a difference in terms of what's the complexity of the topography where your site is located, because part of this is about the science and the kind of context, but some of it is also about operations and how easily will you be able to drill at that site. Other data that you can submit or could be requested could be information on cores or nearby wells if you're lucky enough to have some boreholes nearby. Backscatter data is often requested because that can characterize the seafloor. Again, that can be both a scientific and an operational need. Magnetic and gravity data can be useful. And we've had some examples recently where sort of controlled source electromagnetic data was relevant as well. Not in the official guidelines, but very welcomed by SEP. In some contexts, it can be very useful to have structure maps, sediment thickness maps, isopachs, etc., and digital interpretations. I think by that, Becky was meaning providing, for example, a Petrel seismic interpretation software package. It's not required. We have talked about that, but it isn't required. But if you had something that could be potentially useful, and I think there is a way to upload that. So key requirements for the seismic data, and this is where we get to this point of crossing lines. So your site should be at a crossing point of 2 seismic profiles that image to at least 2 times the target depth. So that's an important point. You can't just be imaging to your target, because particularly from a sort of safety perspective, there'll be a need to understand what's underneath it and whether there are potential safety hazards below. But also from the geological perspective, you want to know what the context is of your target that you're drilling. So, you know, geologically, you would want to know that anyway. If the stratigraphy is simple and the site not structurally complicated, you may be able to have a site on one seismic profile. So there isn't 100% requirement for a crossing line, but it does have to be in a simple situation, stratigraphically and structurally. Providing nearby seismic lines that provide additional stratigraphic and structural context is also very useful, and that can sometimes be very important if you are not on a crossing line, but you've got nearby lines that actually provide that kind of context. And I should point out, we've got a perfect example here from Corinth, where we've got 2 lines that are perpendicular. When we say crossing line, it has to be a sufficient angle between them so that you are actually giving that 3D context. You know, 2 lines that kind of obliquely cross at a sort of 10-degree angle is not going to be terribly helpful. Okay, so minimum site data requirement. So we talked about that. So here it's suggesting with seismic profiles, you know, 1 second of data is kind of what you need at a minimum, but it really does depend on the depth of your target. But as pointed here, twice the target depth is really needed so you can get the context. In terms of the along profile dimensions of the data, obviously as much as possible of the seismic line is useful, again for context, but it does need to be at least 5 kilometers to each side of the proposed site, and 5 times the distance of the maximum target depth, whichever is larger, if you see what I mean. So this is kind of along the profile. How much of the section do you provide? Ideally, if there are no problems, you should provide the whole thing. And same for bathymetric data. To have that kind of aerial extent needs to be sufficient to actually see what the bathymetric conditions are around the site, not just exactly at the site. So there are differences depending on the type of site that you're drilling and the objectives, which are often related. So for example, I'm not going to go through these, but there's some examples here from different settings. And so it's more common, for example, in a sort of a climate and ocean change proposal, where you might have fairly simple flat-lying stratigraphic section in a deep ocean basin where structurally there's really not a lot going on. And so there, you know, you're more likely to be able to, for example, do it not on a crossing line and have fewer requirements for seismic data and other data sets. There's a point here about 3D grids of multi-channel seismic data. I think that would be very unusual in the case of a climate and ocean change and biosphere frontiers proposal to be asking for 3D seismic data. I think that would be very unexpected. But in some of the more structurally complex drilling targets, particularly on subduction zones, we do end up requiring 3D data, and that's particularly the case if there's riser drilling required. So that's a bit misleading, even mentioning 3D data in this context. As I said, I'm not going to go through in detail, but information is, the detail is available in the site data characterization guidelines. And again, as with the proposal submission guidelines, it's important to read it carefully. And if you've got any questions, you can always ask and we'll try and answer. Okay, so we talked about interpretation, and I showed an example of that. And here's another one, just sort of zooming in some detail. It's very important that you provide interpretation of the stratigraphy and ideally provide some idea of an age model. Of course, in many cases, that's what you're after and that's why you're drilling, but to give some information about what you can infer about age and potentially lithology. In fact, lithology and age information, any information about sedimentation rate is something you have to provide in the site forms in the proposal. So we do ask you to provide your sort of best estimate of those. For example, if you say you want to sample the Uisdean section, you need to basically prove to SEP that you've got a pretty good idea that what you're going to drill is going to be Uisdean, or otherwise the whole thing falls down. And then providing the information on where that information comes from is important as well. So in this particular example that's here, we had made an interpretation of what we thought the ages would be based on seismic characterization interpretation, and we had some shallow piston cores that helped to sort of calibrate that at the surface. And we talked a little bit about velocity and time to depth conversion. So invariably seismic data is in time, and that's how it's recorded. And therefore velocity data is very important because that's how you convert to depth, and that's where your uncertainty comes in terms of the depths of the targets that you want to drill to. So providing information on velocity, whatever you have and whatever you can obtain that's reasonable is important. And it could come in different forms. It could be interval velocities or a sort of a velocity time or time depth model, information from seismic processing. So that data could come from different sources. So those of you that work with seismic data will know there's different ways that you could generate or find velocities, and some of them are a bit more accurate than others. So basically you need something that provides that velocity information. Then you need to provide it both in terms of sort of the numbers, but also digitally in some form to show what you have. And it's often something that we go back and forth on quite a lot. So in this case, we provided a kind of velocity time curve, and we showed what it was based on, and it was a number of different data sets, including some travel time tomography data and stacking velocities, and all incorporated, or even with some sort of theoretical models, just to kind of show what the sort of level of uncertainty was. So the proposal that you put forward has to discuss, as well as providing this information in the site forms and uploading data to the site survey database for a full proposal, you do have to outline what data you have in the text of the proposal as well. So give an idea of what you have, what you think you need, and what your plans are to collect whatever it is that you need. And then when you get to the full proposal stage, to also upload that data to the site survey data bank or database, can't remember. And then in the SEP meetings, as I said before, the panel is composed of a third of the people are site data specialists, and each proposal will have 1 or 2 site watchdogs assigned to it, and they'll have a look at the data carefully. They'll also load up the data and check that everything is as it should be. And one of the big problems we often have is being able to get the location of the site matching between the different files and the site location that's given. And of course, site positioning is really crucial because that's something that you really need to know that you're drilling at the right site. So having consistency of the information is really critical. I just noticed that Uisdean is here. I don't know, Uisdean, if you wanted to take over. I'm not quite sure.
Well, I think you're doing a great job. I think you're doing a great job, Lisa. And yeah, I think you're nearly at the end as well. So
okay, I'm just giving Becky's talk. So
happy to chip in when it comes.
Yes, you can always chip in and add something at the end. Okay. Yeah, so the site survey data bank can get very filled up with hundreds of data files for just one proposal, and it's quite complicated navigating your way around it. The Science Support Office, which is based at Scripps, have been doing quite a lot of work in trying to improve the SSDB so that it means that you upload your data in a way that reduces inconsistencies and helps to order things, and also helps the SEP panel to be able to extract things in a much easier way. So they've done a lot to try and help that, and also try and avoid inconsistencies I just talked about. So try and make it a bit more foolproof. But basically, the bottom line here is it's quite a big job to gather together all your files and upload them, and that's why it's also very important to have this data lead who's got some experience with the types of data and so basically knows how to handle everything. Okay, so I still don't know where I am in this, but so basically in terms of reviewing the data and the site data within SEP, so SEP will advise proponents on the data that are deemed necessary. So the idea is hopefully you have come forward with some data, but even at the pre-proposal stage when you might not have uploaded any data at all, the SEP review will come back and make it clear what sort of data that you would need and direct you to the site characterization guidelines as well. When there are data in the SSDB, they will review all of that data and then give information on very specific points and then general points on the adequacy of that data set and how well the site is characterized and what you need to do to fill in the gaps. And then collectively provide an assessment of whether or not the science objectives of each drill site can be achieved on the basis of what's proposed and the data package provided. So the site panelists are looking at the sort of details of the data, but they're also thinking about can the science objectives be achieved from what has been uploaded and provided. And they of course also contribute to the science evaluation as well, because they have a lot of good knowledge generally. So ultimately, based on the data that are presented and the site that they're associated with, can we be reasonably assured that you can achieve your objectives? This is just a little bit about formats. You don't need to worry about that here in the workshop. Again, there's information provided about that in the site characterization data guidelines, so I'll not go into that. And then we do have a classification scheme for the sites, and again that's explained when the review comes back to you. And the main things are, it's reviewed on the basis of whether those data are sufficient to support the drilling, the objectives, can they be achieved, and there are no or minimal scientific concerns, or other problems. Targets are not imaged properly, data not annotated properly, sites are mislocated, common problem, more data are needed, data are not interpreted correctly, or maybe not at all, that's another problem, structural complications, etc. So these are good things to ask when you've put together your data package and your interpretations. Ask those questions of yourself. Are you convinced that you're drilling in the right locations and to the right depth? and that these problems are minimized so that you know that you're reasonably confident you can achieve your science objectives. This is the classification scheme. So you're aiming for a 1 or a 2, basically. Anything below a 1 or 2 means that you can't go ahead with that site. So you need to be ultimately getting a 1 or a 2. But we always provide information on what you need to do to basically move your site from a 3, 4 or 5 to a 1 or a 2. I keep referring to this. So this is the key guideline document. That's the one to go to. And that's got, I think, just about everything that you need within it. Oh, I keep thinking I've finished and I haven't. I think this is the last slide. Yes. So another thing that often gets asked is, well, how do I get this additional data that I need, particularly seismic data? And sometimes you might find that you don't need to go and collect new data. It might exist. So it's worth looking around in public open databases that are available for seismic data. Potentially industry might have something that's actually available. And talking to people who have previously published seismic data from the area, they may also know of other data sets and could be good to involve them as proponents in your proposal. So ultimately, you may need to collect new data and basically write a proposal to do so, but you may find that there are data that exists that could help you if you look around. And yeah, Damon mentioned some countries do have funding set aside for site survey experiments. And maybe Damon can say something about that tomorrow or now. But you might be lucky and there might be something available that's quite IODP focused for collecting new data. Otherwise, it's a normal research proposal.
Just some points. Clearly, in the next 2 days, we're not going to expect you to rush out and collect some site survey data. But one of the things your teams might think about is who's going to be the data lead. Clearly, there have been strong hints from the SEP co-chair that would be a good thing to have in your team. And also, to search around to find both what data already exists. It's always embarrassing to propose a site and then find out that someone else has actually done all the work you need and you didn't know about it. But also then to work out if, and if you do need to collect data, what data you need to collect. So one of the, so those are key things that your teams can start pulling together. One of the trends, just to follow up from Lisa's comments about site survey funding, one of the trends we noticed a while back was that more and more proposals were coming into IODP that were very close to previous scientific ocean drilling, principally because those were the only sites where there was good enough site survey data to drill further. And of course, that sort of led to a rather focused view of the world. We started to know a lot about some rather limited bits of real estate. So certainly in the UK, we have concentrated quite a lot of our rather limited resource in providing opportunities to collect site survey data. And those are both in the form of grants for desktop studies where you can work up existing data from industry or from other science experiments for to put these site survey packages together, or also occasionally we've managed to sponsor a few cruises to go out and collect some new data as well. Lisa, Uisdean, can you see the question in the chat there from Isabel?
Yeah, I can see that. So how simple does the stratigraphy need to be for drilling in one multi-channel seismic profile?
To you.
Yeah, I mean, I think if on that, if you know your geological setting and you know, let's say you're on the abyssal plain and you've got very flat continuous stratigraphy and you can see on that one multi-channel seismic line that everything is flat continuous bedding with no major faults, no other signs of geohazards, then with the geological context in mind and the seismic that you have, the one line that you have, looking pretty benign. And I think that would be approved. Of course, I'm only on my second. I've only done my second SEP meeting quite recently, but we have seen proposals coming in with a single, sites on not on a crossing line, so just in the middle, some 20 kilometers from the nearest crossing line, and things like that. And some of those have gone ahead in those circumstances, right? So it's not an absolute hard and fast rule that you must have a crossing line, but it really depends on the geology. So, but I would say very simple. If there's any threat of the geology changing significantly within, from, over a 10-kilometer distance or 20-kilometer distance, then you're going to get worried, or rather, it won't pass all the kind of safety hurdles that it needs. I don't know, Lisa, if you want to, you've gone through a lot more SEP meetings than I have as Damon, of course. So
yeah, it's interesting because I actually ended up editing Becky's talk there because it was very much crossing lines. But we have had quite a lot of proposals recently where we have deviated from that. I would say your point on how far away from the site things should sort of structurally or stratigraphically change, it would be smaller than that sort of 10-20 kilometer distance. It could be quite nearby that there's something that's relevant, that changes the context, which means that you need a crossing line, or at least a line that's nearby. I think the best thing to do is to kind of submit what you have and have it evaluated. If you are doing a site survey specifically and you haven't already got input from SEP, then it's wise to collect your data in a way that generates lots of crossing lines, so that you're in a position to select a site. If that's the last time you're going to go back and you're never going to get any more site data, then make sure that you plan so that you can, you might even want to collect some, a single transect, and then look at the data and then come back and collect a series of crossing lines across it to make that crossing point. But yeah, otherwise, to sort of provide what you have and then get some feedback from SEP, because it is a little, it's not 100% clear cut. I mean, the other thing that's interesting is often you have your site on a crossing line, but there's something that's a little bit off. Maybe there might be maybe some evidence of gas or of small faults that's at the crossing line, but just off the crossing line, things look much better. And EPSP moves your site off the crossing line to that location. So that's quite a common situation. It's all about context.
Yeah, because in the good old days, in Glomar Challenger and the early days of Geordie's resolution with ODP, there was the option, particularly in the abyssal ocean, of running a crossing line using a single channel on the ship. Now, we're talking about mission specific here. I was just wondering whether that is ever an option with, say, a geotechnical vessel, whether that could be done.
I mean, I think these things can be done, but I think it's more about at what stage are you basically approving a site and, giving the go ahead. So I think it's because a lot of this is about, right, we've got the information we need to evaluate the site. It can do what it's saying it needs to do. Safety, etc. All of those boxes have been ticked. You're basically saying you'd leave that until the day before you drill it. Well, that's like.
I mean, I was talking about the abyssal ocean. But all the fun wildcat days have gone, I guess, is what you're saying.
But I think in those deep ocean simple sites, you wouldn't necessarily be requiring that crossing line anyway.